5, 4, 3, 2, 1, 0, and boom. In the figure above, AB is parallel to CD and angle BAD is equal to 32 degrees. Angle APC is equal to, and I have 4 choices, A, B, C, and D. Now the first thing I want to point out about this question is that unless explicitly stated, do not operate under the assumption that P is the center of the circle. Now, as it turns out in this particular question, the answer works out as if P were in fact the center of the circle. But if they didn't state that, don't work it out as if P were the center of the circle. Alright? Excuse me. Now that would be more applicable in a paper 2 setting, where they would tell you okay, battery done, might as well. 5, 4, 3, 2, 1, 0, and boom. In the figure above, AB is parallel to CD and angle BAD is equal to 32 degrees. Angle APC is equal to. Alright, so we will need to talk a little bit for this question, so stick around. First things first, the 2 lines between AB and CD means parallel. So AB is parallel to CD, that is how we write it in the notation. And then you have a little angle there, BAD is equal to 32 degrees, angle APC is equal to. So in case you were not sure what angle APC is, look at BAD. Wait, this is BAD. Jeez and ages, Lord have mercy. Whew. Come. Let me get this done now, man. 5, 4, 3, 2, 1, 0, and boom. In the figure above, AB is parallel to CD and angle BAD is equal to 32 degrees. Angle APC is equal to ABCD. Good. So let me talk a little bit about this question. Look at the 2 lines between AB and CD. Those 2 lines mean parallel. So anytime you see that in a paragraph or a line or a phrase or something, it means is parallel to. So in this case, AB double line CD means AB is parallel to CD. Alright? And the next thing we need to find out is what exactly is angle APC. Now, whether stated explicitly or not, anytime you have an angle described by 3 letters, the angle is always at the letter in the center. There's a reason why they put the letter in the center. That is not a coincidence. So if you look at angle BAD, the angle is at letter A. So similarly, for angle APC, the angle we're trying to find would be this angle here. Good? Now, the next thing, the way this diagram is presented, it appears that P is the center of the circle. Right? And as it turns out, if you worked it as if P were the center of the circle, you will get the correct answer. But I want to make a point here, especially if you have to do a question like this in a paper 2 context, where they will almost always state explicitly if they want you to assume that is the center. So they will say the center O or the center C. In this case, they would have said the center P. Good? Now there may be cases where the information might be implied. It may not be stated directly that P is the center or O is the center or C is the center. But by using other information, you could deduce mathematically that C or O or P is in fact the center of the circle. Good? Now, the only way we could do that here is if we assume that AB is equal to CD in length. So the length of AB is the length of CD, which they did not state. Good? So if they had said that AB is equal to CD in length, then yes, if they are equal, if AB is equal to CD in length, and we have these two arrows indicating that AB and CD are in fact parallel, then what we would have would be A, B, D, C, right? I'll call the letters as we have them here. We would have a rectangle or some other parallelogram whereby, because these two lines are equal, and this being jeez and ages. We're going again. Five, 4, 3, 2, 1, 0, and boom. In the figure above, AB is parallel to CD. Angle BAD is equal to 32 degrees. Angle APC is equal to ABCD. Alright, so we had to talk a little bit about this question. First thing, in terms of the notation in which the question is written, you see two lines there between AB and CD. Those two lines signify parallel, right? So if we see that, we could read it as AB is parallel to CD. That is what it means. So we are told directly that AB is parallel to CD, but we also have an indication on the diagram itself, which is to say these two arrowheads pointing in the same direction on line AB and on line CD, which is to say that AB is parallel to CD. So you have more than one indication of particular information in this particular question, and that is usually the case. Sometimes they will leave out one thing or the other. Just looking to see if you will pick it up. So in other words, in some cases they may not necessarily tell you that the line is parallel, but they will put the arrows on the two lines. Good? Or in other cases, they may not put the two arrows on the two lines, but they will tell you that the two lines are parallel. Good? Or they might tell you something else. They might say, for example, that ABDC is a rectangle. If they say that, then you know the two lines are parallel. So the information must always be given, either explicitly stated or implied. Good? Now, the next thing we need to find out is what is angle APC. Now again, unless stated explicitly, now, whether stated explicitly or implicitly, whether stated openly or implied, tacitly, right? So you get some little words there for your vocabulary. Good? For English now, for people who do an English exam, you know. Whether openly stated or otherwise implied. See, we have another way of saying it. The angle is always at the letter in the center. So if you look at angle BAD, angle at the center, 32 degrees. So by the same logic, angle APC would be this angle here, right? At the center point P between A and C. Now, as we talk about center point, generally speaking, it is not ever to be assumed that a point is the center of the circle unless they specifically tell you that, or unless they give some kind of other auxiliary information that will lead you to that conclusion on the basis of sound and valid reasoning, geometrical and mathematical reasoning, right? This is not the case here. The only thing that may have bailed us out in this situation is if they would have stated that the line AB is equal to the line CD in length. So in other words, the line AB is of the same length as the line CD. Now, if they had stated that, then you could assume directly that P is the center. Reason being, if this is a circle, now they didn't say that is a circle, right? So you see how ridiculous we could get, right? And this goes back to a point that I would have made somewhere in another place, in another video, about assumptions. We look at this and we assume it's a circle. For all practical intents and purposes, we could treat it as a circle. But the question as presented here is wholly inadequate in terms of being a sound mathematical question for an exam. So yes, in a case like this, you could get away. People will work it as a circle, and they may even get away working it as if P is the center. But in a paper 2 context, this will not pass. Right? In a paper 2 context, they must state explicitly that this whole thing is a circle, and they must also state, if that is the case, that P is the center of the circle. So as we go through these videos, there will be moments like this where I would throw something out just to raise the consciousness, right? So that you will be aware of certain instances where you operated on the basis of assumptions. So they didn't say it was a circle, right? All we know is that AB is parallel to CD and whatever. So what we're going to do is work this question as if we didn't know what the shape was, and we're going to work the question as if we didn't know that, assuming that the shape was a circle, that P was the center. So let us proceed. If AB is parallel to CD, then on the basis of that, then this angle here we could know would be 32 degrees as well, because this angle will be alternate to this angle. So alternate angles, this will be 32 degrees. Now, as it stands here, everything else we will use from this point on will rely on the assumption that the shape is a circle. Good? Now, that might sound to be nitpicking. It might sound to be, okay, everybody can see a circle, right? I just want to make it clear that is not how mathematics operates, right? If you put in a question on an exam and you have something looking circulish, you have to state that it is a circle. Alright? And that is something that whoever it is setting these things would have to bear in mind. Right? It is not sufficient to just drop something in an exam and expect people to say, well, looking like a circle, so therefore it's a circle. That does not work. Same thing with the angle, as I tell my students all the time. Many times when we do the circle geometry question, there will be an angle that looking like 90 degrees. And they will start working as if it's 90 degrees. And I will tell them, no, don't do that. You cannot assume that the angle is 90 degrees unless you see the little box in the corner, or unless they tell you the angle is 90 degrees, or unless they give you some other information that would lead you to the inescapable conclusion that the angle is in fact 90 degrees. Right? So you might be dealing with a square, you might be dealing with a rectangle, in which case the angle at the corner, the vertex, is 90 degrees. Good? So just be careful about that. Right? Just be careful about that. Right, so we continue. So the only way we could move forward with this question is if we assume that this shape is in fact a circle. And if we assume that, then we have this chord BD, which would subtend this angle 32 degrees at point A on the circumference, but the same chord BD also subtends this angle at point C on the circumference. So therefore, what we would have happening is that this angle here, and I'm going to put it in green just to emphasize that it is subtended by the chord here in green, this angle here would also be 32 degrees. And if this angle is 32 and this angle is 32, then this angle here we could find by using the fact that the angles in our triangle add up to 180 degrees. So in that case, what we will have would be, let us say, this little angle here in blue. Let us call that angle CPD. So angle CPD will be equal to 180 minus 32 plus 32, which would be 180 minus 64, which would be 116 degrees. And if this angle is 116 degrees, then this angle here, right, these two angles of course would add up to 180. So this angle here, which is the angle we're trying to find, would be, we can say therefore now, angle APC is equal to 180 minus 116, which is equal to 64 degrees. Good? So in this case, the answer is 64 degrees, which is the answer B. So we were able to work this out by assuming that the shape was a circle, but we didn't assume that P was the center. Now, if we assume that P is the center, we will also get 64 degrees. Because if this chord BD subtends this angle A, this angle 32 degrees, sorry, at the point A, then we know that the angle subtended at the center is double or twice the angle subtended by the same chord at any other point on the circumference in the same segment, right? A little wordy, but it's one of those things that you just know when you're doing the question. Of course, you'll have to know how to express it in a paper 2 context, because in paper 2 they'll ask you for the angle and they'll ask you for your reasoning, but we will deal with that in another place. Good? So in this case, the angle subtended by the chord BD is 32 degrees here, which is also equal to 32 degrees here. We established that in the first working. But if that is the case, then this angle here must be 64 degrees, because the angle subtended at the center is twice the angle subtended by the same chord on the circumference. Good? Now, if this angle is 64, then this angle here will also be 64 by virtue of being vertically opposite. Vertically opposite angles, this will be vertically opposite to this, and we know that vertically opposite angles are equal, so therefore this angle would be 64. So this question is a good question in the sense that if they had stated explicitly that the shape was a circle, then we could work it without even assuming that P was the center of the circle. And if they had also stated that P was the center of the circle, well, then the working would be even shorter. In this case, they did neither, so we were left to assume, 1, that the shape was a circle, and 2, we may or may not have assumed that P was the center, but we definitely had to assume that that the shape was a circle, sorry. Alright? So again, at the risk of being repetitive, right, this question is yet another example of a situation where vital information is left out of the question. And you get away with it simply because the context in which you're operating is one where everybody more or less could figure out what you're trying to say. They know what they mean, right? I just want to again make the call for more specificity, if I could use that word, when we set in exams, when we set in questions in an exam, right? Whether it's the regional body, whether it's the local body, whether it's a teacher in a school, whether it's a teacher in a lessons class, etc., etc. If you're setting an exam in a maths paper, make sure and put the information, right? We don't want to get into the habit of, well, whatever, they could see it's a circle, so it's a circle. No, that is not the standard we'll be looking for. Alright? So whatever level you're operating at, wherever you're operating at, if you're setting questions for somebody, please put the information. Make sure the information is included either explicitly or implicitly. Either way, the information must be there. Alright? So that's basically it. So in this question, whether you assume it's a circle and you didn't assume that P was the center, or whether you assume that the that the shape was in fact a circle and P was in fact the center, in both cases, the answer is answer B.